6/9 now. Didn't make any mistakes there, did we? Hey folks, welcome out there this afternoon to T and Learn Mathline Summer School. Hey, the music's playing. We're here. I'm Ernie Roberts, and I'm your host for this afternoon's session. Hopefully you're having a great summer so far. You know, can't believe it's already half over, and goodness sakes, what more can we ask for? We've got a great math line for you this afternoon. Now, as you well know, this is not a call-in math line, but those will resume. Yes, they're coming soon. Second week of August, all right? You don't want to miss out on that. And school will be starting second week of August, maybe earlier for some of you. But you know what? We're here to help you get a little refreshed, remediated, and maybe even learn a few new things this week, all right? So thanks for tuning in this afternoon, and let's see what's going on this afternoon with T and Learn Mathline Summer School. What you see is what you get. I like that. Sort of what you get every day on Mathline, right? What you see is what you get. But we're going to focus a little bit more on these parallelograms. One more round, actually quite a few more rounds. We're going to be dealing with them for a long time. When we do 20 minutes or 25 minutes, 30 minutes a day with you here on Mathline, which is about what we wind up getting to do, counting, you know, all the other good stuff going on, we sometimes don't get to complete topics as thoroughly as I like to anyway. But this is kind of nice with the parallelograms. We're taking them step by step, and also we'll be bumping off into rectangles, rhombus, and square moments in the following shows coming up this next week. So hang in there with us today. We're glad to have you with us. Let's see what we've got going. All right, first thing here, summarizing where we've been, and where we're going to go probably. First of all, I've got a figure that looks like a parallelogram. Let's put some letters on it, all right? We always like to make those, and again, it's not necessarily how you put them on there, but when we get those letters on that figure, we're going to have to call them certain things if we're going to say this is a parallelogram. And since we have said parallelograms here, let's say this is one. Now you say, Ernie, how do we know? Well, if they tell you this, you've got this notation. Here's the parallelogram symbol. And we'll start with A, B, C, D. Now notice what we did. We picked A, went to B, C, and D. These move, well, this one really moves and looks like a counterclockwise direction, all right? We could have also gone A, D, C, B in a clockwise direction. But we don't jump around. We don't go A, C, B, D and name the points. We want to get a pattern and stay with it. Either go clockwise or counterclockwise. So that's the first thing. The next thing says both pairs of opposite sides are parallel. So let's pick those out. Here we go. We can mark those very nicely. Right there you are. And mark those up the figure. Again, these are notations that you see that symbolize, parallels, all right? They're not tick marks for congruence. We're going to talk about that in a little bit, all right? But not tick marks at this point. Now, what we can say about those sides, opposite sides. Now, notice once again, opposite sides are the ones that don't intersect. They do not intersect. So we've got AD running parallel over here to BC. See how those are going? There we go, there we go. And we also have AB on the horizontal running parallel to DC, or we could say CD. All right, once again, we're talking about line segments. Doesn't matter where the order of letters go here, all right? In other words, AD is the same thing as DA. BC is the same thing as CB, and so on. So there's your first situation. Now, second little piece of information I said, let's put a diagonal. By the way, it says each diagonal will work. We're only going to look at one, all right? We're going to just play one in here. And for those of you who saw this before, we're not going to prove out the triangles. We're just going to go ahead and mark some things here. But this little guy here, this diagonal, acts like a transversal. There are a lot of things that are happening here, a lot of things that are happening. First of all, we're getting a lot of alternate interior angle pairs. Well, two of them at least. 1 and 2, there you go, that's a pair. But also based on AD and CB, we got we'll call it 3 and 4 here. We've also got another pair of alternate interior angles. We have, congruent reflexive moment there. So these triangles will be congruent by angle, side, angle. Quick update on those things. Now, naming those triangles, very, very important. So let's go with triangle. First of all, how about it? DAB. Now notice what I did. I started with angle 3, went to A, and back to angle 2 in that triangle. So I need to match the shapes. I need to match the shapes as well here. So I've got a rather large angle, 3, comparatively to 1 anyway, it looks like. And that would be the same thing with 2 and 4. So we're going to start with B. When we're starting to name that triangle, we're twist it around because that's what happens with parallel lines and alternate interior angles. Things get a little twisted in there. We definitely know that C matches with A. That's a no-brainer. And then we got one letter to come back to. It looks like it's going to be B, C, D. So there's your matching pieces. And I want to point out something else to you. Well, we're going to point out something else to you. That means that we've got all corresponding parts. That CPCTC would come together, and that gives us some more interesting concepts for the parallelogram, which we're going to explore a little bit more today, all right? So let's see where this is all going to go to. We've got triangles wrapping around here for us. They are congruent. There are a lot of congruent parts. Actually, there are 6 congruent parts with each pair of triangles. Once they're congruent, we got 3 pairs of angles and 3 pairs of sides. So lots of good things to work with. So let's take a look at one of those things. How about it? Let's go to what appears to be the relationship between each pair of the opposite sides of a parallelogram. All right, so we've already established a parallel. We know that, all right? But also there's another thing going on here. What's a new relationship? How about congruence? Remember when we drew that diagonal in there, we had congruent triangles. And my friends, we had, oh my goodness, we had these pair of sides matching together and these pairs matching. You say, well, what you see? What you see is what you get. What does that have to do with here? If you draw a really true parallelogram, you're going to be pretty much able to say, you know, I might not remember exactly the rule there, but there are congruent pattern here. All right, you can see that DE, GF are the same length, as well as, how about it, DG and EF. Now we go a step further, maybe talk about angles. Do the angles look like they are? I believe they are too. And if you remember, one of those pairs did match, okay, when we drew our line earlier in forming the 2 triangles. But both of them actually will. So these 2 would be congruent, these 2 will be congruent, but we'll get into those a little bit later. Those are the opposite angles. Right now, let's focus on opposite sides. So let's name them. Let's name them. Again, opposite sides are the ones that do not intersect, right? Do not intersect. So let's go with it. DE, right there across the top, is running, well, it's parallel, but we're going for congruent now. All right, so we're going to pick up congruent to GF. Now, like I said, they're also parallel, so let's not forget that. Let's not forget that. DE is also parallel to GF. But we've established that. We've established that because that's the definition of the parallelogram. Now, let's pick up our other pair of opposite sides. How about it? We'll pick up DG, and we'll make it congruent to EF over there. And let's see, how about it? DG running parallel to, we dropped the bottom out there, guys. Come on. Thank you. To EF also. There we go. So we can see everything. And that is our story on what the relationships are. All right, we've got congruence there. That's the new biz. This was the old stuff. So what we're going to say here, just to sum up what we've done, opposite sides of a parallelogram are congruent. Now we know they're parallel because of the definition. Now we have what we call a theorem, all right? A corollary perhaps, some people will call it. But it results from the fact we have those 2 congruent triangles earlier. This makes CPCTC. And also, by definition, those opposite sides are parallel, all right? Or parallel, however you want to look at it. But they don't intersect, all right? They don't intersect. And the congruence factor. Does it work for any other quadrilaterals? Well, if we go to rectangle, rhombus, and square, yes, it does. But if it's not a parallelogram at heart, to begin with, this cannot work, okay? Opposite sides, both pairs of opposite sides will not be congruent. Certainly won't all be parallel either. So they work together. Got to go together on that, all right? So that's our good stuff there. So what do we do with it? Let's put some numbers to this stuff, all right? Let's put some numbers to these pictures. So let's see what we got on our next one here. Those of you tuned in the last show, you probably saw this and said, well, I remember what to do. Let's see if you remember, all right? We have two sides of a parallelogram with measures 12 and 15 meters. We're going to find the measures of the other two sides. All right, now, let's go back and think a minute. Surely these can't be the opposite sides because remember, 12 and 15, you're asking, well, Ernie, how do we know which one's which? Well, I'm going to use my eyesight a little bit here, and I'm going to say this one, I'm going to put 15 because it looks a little bit longer than this side over here, which we're going to call 12. Not much difference, and that's kind of true. Now, what happens, though, is we do know if it's a parallelogram, that's what we're saying. It's a parallelogram, so we got a parallelogram working here. This means the opposite sides, this one is going to be congruent to this one down here. How about that? And this little guy over here should be congruent. We'll tick it out there to this one, all right? And that's going to give us 12. It's going to give us 15. And you know what? You have all the sides that you need right there. Now, what if you ask for perimeter? We could go to perimeter. We could look at it adding all those together. Or we could say 2 times 15 and 2 times 12. And that's going to give us, looks like 30 plus 24. And we're going to get, how about it? Y'all ready for it? 54, not square meters, but meters. Now remember, meters are just the perimeter. It's just a nice unit. It's a nice linear measurement. If I wanted to go for the space that's inside that dark purple blue area there, you know what would happen? We would have to figure out height, which we do not have, by the way. 12 is not the height. So in no way are we going to use square meters in this problem. We need to find the height. We don't have it yet. That's another show, all right? It's another show. But that's where we are. That's basically a little arithmetic. So let's do, you know me, I love to do a little algebra, all right? So let's do some solving for x's and businesses and such and show some more applications for these lovely parallelograms. Let's take a look at this one. And once again, notice we have A, B, C, D. Now look this time. We picked up on A, B, C, and D. It's still, once again, when we see this given to us, in an order, that basically means we're clockwise or counterclockwise. Now, notice something else from here. A and C become opposite angles. B and D become opposite angles. Do you see that? Everybody see that? They're very much disconnected from each other. And also you can look at AB and then CD. Look how they run. Here you are. And also we can come out and go out to AD, the outer pieces, and then the inner pieces. So that's some options for being able to work with this, all right? So let's see what we've got. We've got AB equaling to 45. Might be meters, might be inches, might be feet, who knows, all right? And down here we've got 3x plus 9. Now, if this were not a parallelogram, we'd be burned, okay? If it were not a parallelogram, we'd be burned because we couldn't do anything. But since we have that symbol, yes sirree, that symbol parallelogram, that means not only are they parallel up here, they're also congruent. We'll put that there. I'll put 2 ticks there. Some of y'all like to be consistent. Now these guys over here also are parallel and congruent, but no information about them, right? So this is where we're going to work. We're going to work with A, B, C, and D. Right there we have it, all right? And again, that's the ordering. That's the ordering that we've got going. So let's take a look. What do you know? They're equal. Let's do a little algebra. This one is actually an easy algebra. 3x plus 9 will give us 45. Very straightforward because basically the quantity 3x plus 9, we're going to set it equal there. Now remember a little algebra 1 coming back here, maybe actually some pre-algebra for a lot of you guys. We're going to remove the 9, and we're not going to add 9 to 45. We're going to subtract that 9. Both sides, remember we do both sides. And that leaves me with 3x, and on the other side, I'm seeing 36, all right? Now just think about your money. $45, take away 9, whew, you still got 36 of it left, all right? Let's now divide through by 3, okay? And that's going to give me x equaling to, what goes in there? That's easy, right? Easy division. It's going to give me 12. Now, you always like to check, right? You know we've got to have 45 back from this expression, so let's see it. How about it? 3 times your 12. Add 9 to that. I'm seeing it. 36 plus 9 45. And yes, folks, you can do that mentally. You can do that mental check. But what I want you to make sure is that your answer, when you solve for x, makes sense. All right? And the sense here has to be that you got to get 45. You got to have the same measurement because what? Opposite sides of a parallelogram are congruent. That's our story today. What you see, what you get, you know those have to be the same length. They are. They're both 45 meters, feet, inches, whatever units you want to put on them, okay? So that's our deal. That's our deal. What you see is what you get. And also what you see is what you get with me, all right? Sometimes I wonder, are you going to ever change? I don't know. We'll look at it. We'll look at it. How about it? Let's see our next problem. A little more complex problem here, but let's see how we're going to work through it there. Whew, it's complex to some of you because I put a fraction in there. Well, we got a nice figure. We got the parallelogram, and you know what, folks? We could have created this parallelogram, but it helps a little bit seeing where the letters are, all right? For simple reasons, you never know how long or how short these segments are going to wind up being, and in many cases, when you've got variables and everything, you really don't know who's going to win out. I'm giving you a little hint. This one is winning out, all right? With the, looks like the y values are going to give us longer stretches here with D, E, and C, F. Now, I think a picture's worth, as they say, is an old cliche, I know, 1,000 words, but I'll tell you something. Once you put these on your picture, and you know, by the way, it's a parallelogram, right? C, D, E, F. So let's put those together as congruent. These are congruent. Once we put our expressions on the picture, it makes it a lot easier. Makes it a lot easier. So here we go. Here we go. Everybody with me? Let's put it on here. We got 1/2 x plus 9 right there for EF. Oh, I skipped CD. Sorry about that, ladies and gentlemen. Actually, I skipped a lot of them, didn't I? I just like that fraction. I don't know, it kind of gravitates. 2x minus 6 right over here. We're going to set those equal to each other, which is nice because we only have one variable to mess with this time, all right, between those two. Now, we're going to play the same game here with DE running across the top. We'll put a 3y plus 7 right up there on the top, all right? And down here underneath, how about it? Y plus 15. Now, we need two equations. We need two equations. Wow. All right, so let's go with it. I'm going to draw a little line right down through here. Let's do some work off here to the side. First of all, let's do the x's. You know, it's a fraction. Some of you get really nervous about fractions. Let's just go there first, all right? So here we go. It's going to be a 2x minus 6 equaling to 1/2 x plus 9. That took a lot of space, didn't it? Now, let's do this. Let's get our x's together on the left, which means we've got to subtract. We've got to subtract that 1/2 x. On the right, keep the 9. Keep the 9. Over here, we got to subtract 1/2 x also. So here's the deal. Don't lose your 9, all right? It's going to give us a 9. That was easy. Now, what happens when I take 2 subtracting 1/2? I get 1 1/2. Some of you all like 1 5/10 as a decimal. That's fine. So we got this, and we're going to subtract the 6. We need to move the 6 over. So right here underneath it, we're going to add 6 to both sides. And I've got 1 1/2 x equaling to 15. Think about it. Think about it being 1 1/2, 1 5/10, 1.5. Divide by that, or change it to an improper fraction, 3/2, use a reciprocal. You're going to end up with x equals 10. X equals 10. There's half the battle. Now, let's come back over here and let's figure out what the y value is. Whew, we got a lot still to do. I may have to drop my picture out again here in just a second. Let's go with 3y plus 7 equals y plus 15. All right. Again, we're going to subtract y from both sides. It's going to leave us with 2y plus 7 equaling to that 15. Remember, the y's go away. And we now have to subtract 7. Let's see where we go. And we're going to end up with, looks like, 2y equaling to 8. And that y gives us 4. So you say, all right, Ernie, you got 10. We got 4. Let's see what we're going to do. We're going to just put it right up here. Put the 10 right here. put the 10 right here, and do a mental check for our arithmetic here. Put a 4 here and a 4 down here. And let's see where we end up, what we end up with. I see 3 times 4 plus 7, it's going to give me 19. There's 19. Over here, we have half of 10, which is 5. How about it? We get 14, is that right? 5 plus 9 certainly is 14. Well, you know, I have to get 19 back over here, don't I? Because opposite sides congruent. And while we're finishing up over here, wow, another 14. Another 14. Add them together. Add them together. Wow. Let's go down the side here, one more notch. Let's go down here. We're going to add 19, 14, 19, and 14. And you know what I'm seeing? I'm seeing a pretty healthy size of a parallelogram there, aren't we? Let's see what we get. We get about it, 33 and 33. I believe that's going to work nicely for us there. What's 33 and 33 going to give us? Ooh, I hope in 66. Are we correct? Are we correct? Well, let's see. I always get a little nervous when we get to this point. Let's try it. 33, 33, and 66. So again, whatever units we're working with, 66 equals the perimeter. And again, that's a thought problem. That's a problem where you've got to work through a lot of things and come back and don't get too excited. Take it step by step. Find your x, find your y, work your figure. This was easy mental math. I think it was easy mental math. I hope each of you did too. And then add your results. 2 19s are 38. You could also do that, 2 times 19. And you could also use the 28. Adds up, either way you do it, 66. There's your perimeter, all right? So, a nice quick problem. Well, took a little bit of time, didn't it? But you know, working your algebra, that's important, all right? Let's take a look at one more here. Let's do a quick setup on this, see what we've got going. We're going to solve for x and y, not having to worry about perimeter. Again, like I said earlier in the last problem, put your information on the figure, all right? So we got 12 out here for DE. We got, how about it, 4x over here. That already tells me something. Does it tell y'all something? I hope it does. It tells me that we're going to have an easy value for x, all right? This one's going to work a lot quicker than that last one did. We got 10 plus x right here. And up at the top, we got 2x plus y. You say, Ernie, you threw a y in there. Now, why didn't you do that? Make you think a little bit. Make you think a little bit. This is kind of like an ACT type question because it works pretty quickly, yet if you know all your tricks, by the way, yep, they are congruent also. They're congruent also. So once we get rolling here, and the easy part is, right off the bat, we can figure out 4x equals 12. So x is equal to 3. Now that was easy. How did I know that? Divide 4 into 12, get 3, all right? So by the way, you know that's going to give you 12 when you put that 3 in there, all right? So that's the whole side is going to be 12, all right? So 4 times 3, there you go. Now, I also gave you another little hint. We're going to say 10 plus 3 right down there, all right? So we'll put a 3 in for x, put it right above it. That's going to give us 13. So I got 12, 13, and 12. Guess what? I have to have a 13 up here because opposite sides of a parallelogram are congruent. Exactly, exactly. So let's go back here and see where we are. Let's put it down here. I've got 2x plus y equaling to, what is it equal to, folks? Ah, you got it, 13. Equals 13, exactly. So put that 3 right there. So we'll put 2 times 3. We'll add y equal to 13. I believe it's going to come out sweet. Nice. Let's see, what do we get? 6 plus y equaling to 13. And our y value, just subtract that 6 off, should be worth 7. So quick check, quick check. We already know x equals 3 is on it, okay? Because 3 times 4 gives us 12. 12 is, that was easy. We also know 13 is part of the answer because once we get x established, we keep it. We don't lose it. We don't change it. We just keep running it through, running it back and forth there, all right? So that's going in. And up here we substitute. 2 times 3, you know that gives you 6. That's what we did right here. And we're going to remove the 6 back to 7. And you know what? 2 times 3 is 6. Add 7. Ding, ding, 13. We got it. 13 is where we are. So there it goes. It's not difficult if you keep that thing in mind. What you see is what you get. Those opposite sides, not only are they parallel, they're going to be congruent as long as you have a parallelogram. Opposite angles, the same story. You know what? It's going to be a new show because we're about out of time for today. Sorry about that, guys. I told you we might have a stretch on these things. We'll get to the angles on our next show, all right, or on a later date. Thanks for tuning in this afternoon. We always appreciate it when you do. We know it's summer school. We get a little bit laid back here, but we still try to tax you a little bit. That middle problem there was a little bit long, wasn't it? But you know what? That's okay. You're watching Mathline, right? And you can handle them. Hey, thanks for tuning in. We'll see you again, hopefully back again the next time. You know it.